Hey guys, just about to reinstall the board back in the chassis, but just before I did, I went hunting and finally found my stash of C0G type ceramic caps, so I rebuilt that integrator again and took out the plastic film caps that I had put in there. C0G is one of the most temperature stable ceramic dielectrics out there, and also has a nice property in that it maintains the capacitance as voltage across the capacitor increases. The cheaper types of ceramic don't. They actually lose capacitance as the voltage across them increases. So you definitely don't want to use those in a sensitive timing or filter circuit. So with that out of the way, time to reinstall it. I've got my laptop handy with all my reference photos. So this has to go back up under there, and I need to get the shield installed right, and then there are these metal plates like you can see over here that go against the board. Kind of curious. Not entirely sure what metal these are. I want to say it's aluminum, but it's a little more heft than I would have expected. But it might very well be aluminum. And they go across the board, and the screws go into that. Why they did it like that, I'm not entirely sure. Maybe it was just to save some time. I imagine these scores are there so they could break them off to length as needed and then drill holes in them. So it seems to me they could have just used individual washers or sheet metal screws that have kind of a washer built into the head instead of using these long strips. I don't know. But anyways, that's what they used. That's what I'll put back in. And then hook up all the wires again. Alright, waiting for the set to warm up. That's a good sign. We got sound and we got a very distorted picture. But that's good, because I did change stuff out in the vertical. So one issue I was having is the vertical hold I would lose as the set warmed up. So I was just playing with the control just then. It's locked in now. Let it sit for a while. So we've got a very crushed linearity. Not unusual when you change components in the vertical circuitry, because I had already adjusted it before with the old components in there. Now I got new components, so I need to tweak it. Awkward thing to do in this set. This is a reminder where they so inconveniently placed them. Is down in there next to the horizontal output tube. It's hard to even show it on the camera, so kind of right there in the middle of the screen. So I'm going to get a long flat blade screwdriver and get down in there. Before we do that, oops, I got some marking down here. I want to see how the high voltage is doing. So I got my high voltage probe and meter. 10.5, still low. And the boost 320, still low. Alright, so I have not put in the new 6BG or 6DQ6 horizontal output tube in yet, and a few other new old stock tubes I got, so I'm going to swap in the new tubes and then play around the linearity controls and get a good picture, play around with the drive control a little bit, see what kind of high voltage I can get, and if everything is still low, then it's time to try the yoke that came with this set. Well, I think I may have solved the problem. Not what I expected. So, here's a 6DQ6 I just had in the set. Here's a new old stock one. Nice GE tube I was about to put in there. However, when I went to install it, I noticed a little something inscribed in the chassis. It says 6CD6 or 6CU6, not 6DQ6. Why do I keep putting 6 DQ6s in there? Because that's what the friggin' schematic says. So, even though everything else on the schematic matches this stupid set, that must have been one of the revision changes at some point, even though all the resistors and the bias on everything match the schematic, it's supposed to have a different tube in there. Now, that may be backwards compatible. It might not make any difference. I don't know, but let's try putting the right tube in there. I hope I have some. Now, luckily, these are also used in Predictas, the Princess, the Debutante, the Siesta, and I needed some of these anyways, so I'm glad I ordered them. But let's see if I can scare up a 6 CD6 or 6 CU6, and I got to go back through, all the way back to part 1 and see what was in this set originally when I got it. Did it have a DQ6 in it, or did it have the right tube? I don't remember, it's been way too long, but that tube number does not really ring a bell. Hopefully I've got some somewhere. Okay, eventually dug up one of each. Although this is a GA version, and I just noticed the plate cap is a bit fatter. This is the first one listed as CD6. However, it does say or a CU6. So that's what I'll try. And you can see they look pretty much identical, and I imagine the specs are similar. The pinouts are probably the same. So pop this guy in, see if it makes a difference. Well, unfortunately, that's even worse. Now we're down to about 9,000 volts. So I haven't tested that tube yet. It could be weak. I don't know. A little frustrated. Found a couple of these, the CD6, but they're both GA versions, which have a larger plate cap and physically larger tubes. So I'll try. I don't know that that plate cap's going to fit on here. I don't think it will. I've looked through most of my tube stash. I got maybe 1 or 2 more boxes I can dig through. Otherwise, I might just have to order one. Okay, I did a little research, and it turns out that the 6CD6 is a big beefy tube. It draws about 2.5 amps in a filament and can take a pretty hefty voltage and current. And this is what the original ST looked like, and it evolved into this, which is a larger plate cap than that can handle. So I think that is a misprint on the chassis. To further back that up, I looked inside the cabinet, and the label on the cabinet said 6CU6. So I looked up data on a 6CU6, and it actually is very, very similar to a 6DQ6. And actually, a DQ6 is a little bit of a superior tube. It can handle a little bit more voltage and current, and they have similar gain. So I think a DQ6 actually is an okay sub. But the data sheet indicated that a BQ6 was an even closer sub. In fact, some tubes are labeled as both CU6 and BQ6. So I dug up a 6BQ6, put that in there. Performed even worse than the CU6. I was down to about 9,500 volts. I checked the 6CU6 I'd pulled out, and it tested just fine. So, put it back in the set. And I dug out my 8XP4 that's not in a cabinet. Not like that. It's just a bare tube. Hooked up the original yoke that goes with this set. Ran high voltage cable over to it. Got a chance to use my little adjustable neck holder thingy. And just use the box that neck came in to further support it. And I got the yoke plugged right into the chassis. So original speaker, original yoke, everything. And I've got my high voltage cap here, substituting for the Aquadag coating that's not on this picture tube. So that's as close as I can get to the normal operating environment, short of putting it back into the set. So let's see how this goes. If this is still no good, well, then I think I'm going to replace the resistors on the horizontal output and damper sockets. I still have all the originals in there. They test okay, but in operation, carbon comps can sometimes get a little weird. why. I've had this problem before. I think this damper tube socket's a little wonky. There it goes, the tube wasn't lit up. Oh, there we go. Clearly the yoke is not correct. I'm going to go in the wrong orientation. That's alright. And as for high voltage... Oh, got it in AC mode. That's not going to work too well. Better. Almost 12. I was getting about 10. With the other yoke, I can adjust the drive, maybe get a little bit better. See if I can manage to rotate that yoke too. Well, unfortunately, I'm getting nowhere fast with this set. Putting the original yoke in the set has made no difference whatsoever. I've done more voltage checks and replaced the resistors and horizontal output tube. No difference whatsoever. So kind of went back to the drawing board, and as some of you suggested, maybe voltages, waveforms on the SAMs aren't correct. So I got service control from the riders, which is for an older revision run. Well, it says run 1 through run 3, and this thing is run 19. So circuitry wise, this matches the SAMs perfectly, except for that horizontal output tube where they say a 6DQ6, whereas the tube chart is a 6CU6. So look at the riders. Right away, some differences, like it has a 6AL5 tube instead of the diodes, solid state diodes. And some of the resistor values are a little different, like this guy down here is where I have two 18K resistors in parallel. This is the single, I think it's a 5600 ohm resistor. Alright, but that aside, everything else is pretty much matches. And check this out. So one of the issues I had noted in the SAMs was a plate voltage in the horizontal output tube. They show, none of the horizontal output tubes, sorry, the tube that drives a horizontal output tube. Okay, no, sorry, and that's another difference. They show a 6CG7, whereas I've got a 12AU7, which probably should have told me maybe I shouldn't be using these voltages as a reference, and they're using a different tube. So they show, was it 255 on the plate? On this with the 12AU7 like I have, they show 165, which is more in keeping with what I've got. Same goes for all the other voltages in this area, including the grid. I've got right about 110 volts peak to peak, whereas the SAMs showed 70, so that was a potential problem too. But nope. According to the riders, which generally is a reprint of the original manufacturer service info, 110 is correct, and I also have minus 30 volts on the grid like they show, and so on and so forth, to everything except for the boost voltage being low. On this, the SAMs and the riders do agree. Likewise, the high voltage in the picture tube should be... Actually, they don't show it on here. That's curious. I could have sworn they did. But I know it shouldn't be 10,000 volts. You can look up the data on the tube, and a 21-inch picture tube from this era is not going to work well in 10,000 volts. 15,000 is definitely more in keeping with what it should be. So, the remaining issues are high voltage is low and the boost voltage is low, which I think accounts for the vertical issues I'm now seeing now that I've rebuilt that whole board. Vertical lock is great, but I can't get the linearity and the height looking right. Sure, it's a little baby CRT. So the only way I can find out if the vertical is giving me full deflection and decent linearity for sure is to hook up the real picture tube. I don't think that's going to do anything for my boost voltage, and it's not going to magically make the high voltage increase. So what the heck is left? So if the horizontal output tube, I got the correct tube type in there, both the voltages on it are right, all the component values are right, the drive voltage is the correct shape, frequency, and voltage peak to peak. What the heck is left? I've replaced the high voltage rectifier and damper tube several times, and associated components, except for these guys. I replaced that cap, oops, sorry. But that resistor is just slightly high. Don't think that's really going to be an issue. And then there's these guys. So that's the latest thing I've been playing around with. Those go to, it's a little hard to see on this version of the schematic, so I'll go back to the SAMs for that. They show them right here. So the horizontal yoke actually has a tap in it, and then it goes through a resistor to those two caps, which are then going across the entire yoke. Those form a filter to take out ringing, so I actually clipped that resistor out to see what effect it would have, and I'll give you a little look-see. So, what's left? Well, I swapped out a few horizontal output tubes, but all the ones I have are used, so I ordered up a new old stock 6CU6. So kind of a Hail Mary. What's left is the flyback could be bad. Now, it seems to me that since I have a decent picture, it's obviously not shot. I have high voltage, I have a good picture, I have decent linearity. So it's not open, but it could potentially have short. However, this is the type of flyback that's an autoformer. So there's really just one main winding, and there's a loop around there to drive the filament on the high voltage rectifier, but the rest of it's just one long winding. But potentially there could be a short in the section that's just used for making high voltage, and that wouldn't affect the picture, maybe. Anyways, what I wanted to show you right now is with that network clipped out, we've got vertical stripes over here. That's without that filter being in place. If I carefully get in there and hook it back up, they go away. Here it is out. So that's what those are for. So even if those components are a tolerance or bad, I don't think that's going to really affect the high voltage any. Another really remote possibility is that somewhere in here there is a partial short, high leakage inside the high voltage box, even though I don't smell any ozone, don't hear any arcing, don't smell any burning. Potentially there's a little bit of leakage somewhere. Or in this wiring, this is the stuff going to the damper tube and the yoke socket. Some of these wires look a little hardened and they're kind of rubbing up against other things. So if there was some partial insulation breakdown. Again though, I would think there'd be some noticeable defects in the picture, or noticeable kind of burning smell or something, and I'm just not getting any of that. So what's left? 15 ohm resistor, it measures about 16 ohm. Don't think that's going to make a massive difference. These are those two caps and resistor that form that ringing filter. And it's going to make a huge difference. And this resistor and these two caps back here form a vertical retrace suppression pulse. I believe, yeah, it's that guy right there. That's so you don't see any retrace lines. I could cut all that stuff out, it wouldn't make any difference. So the boost voltage drives one of the elements on the CRT G2. So with that being low and the high voltage being about 40% low, I think the picture is going to be a lot dimmer and probably a bit out of focus from what it should be. That stinks. Everything else seems to be working fine in this TV. Another remote possibility. So there's a loop. This wire goes into the flyback. There's a loop around it, and it comes out and drives the filaments. If for some reason there's not enough juice going to that, the high voltage rectifier tube will not be running as effectively as it could be, and it could be choking the high voltage a little, maybe. But again, that wouldn't take into explain why the boost is low. Which gets me back to the horizontal output tube isn't pumping enough juice into the flyback, which could be because this tube isn't right. I will hunt around again. It seems to me the 6DQ6 is a pretty darn good substitute, and it seemed to give me about another kilovolt or so of high voltage using one. So I might play around with using some of those a little bit more. I picked up 4 new old stock, or maybe 3. I've only tried one of them so far. I've got 2 more I could try putting in there. The tough thing about these tubes is when you get into power tubes, high voltage rectifiers, damper tubes, you can't really test them very effectively in a tube tester. It'll tell you if they've got a short. It'll show you they've got a emission. But these tubes run with a lot of power going through them, high voltage pulses, stuff that a tube tester just isn't going to simulate. So sometimes you have to go through half a dozen horizontal output tubes to get one that'll give you good high voltage, good linearity, full width. But yeah, getting a little frustrated. Well, now, interesting development. I put in one of the Sylvania 6DQ6s, and I had put in a new old stock damper tube that I also ordered, but I went back to the Sylvania that I'd been using since I started working on this set, and check this out. Boost voltage, 518 volts, 517, it's supposed to be 520. That's close enough for me. And as for the high voltage, I could tell when this thing powered up there was more. I'm not even touching this probe to it yet. You can just feel it, you can hear it. We've got a lot more high voltage. 13 according to this. Actually, I don't even have it attached. I think I got 13. Sorry, this multimeter. There we go. It's not backlit, so it can be hard to see. And that is without any high voltage filter whatsoever. So I'm going to try tacking that high voltage cap I'd been using back in there. So, I guess I just proved what I was saying about these sets can be really picky with tubes. So I've got a 6DQ6, not the 6CU6. When the new old stock one arrives in a few days, I will pop in and see how that works. But otherwise, I will make sure I mark this one as this one seems to work pretty well. Same with that damper tube. As for the image, the scan lines do look a lot sharper to me. I'll have to hook up a signal source. Alright, things are looking a lot better. I got the filter cap on the high voltage. It's up to about 15,500 volts. Tweaked linearity, and I'm going to do as much as I'm going to bother without putting a full-size picture tube. One thing I'm not really crazy about now is the picture's a little grainy. I think it's because I don't have the greatest connection with my signal source. I think the antenna terminals might be a little corroded, or I don't have the greatest connection somewhere along the line. Not quite sure, but otherwise everything's within spec, everything's working great. So that leaves me with cleaning up a bit of my work. I had snipped the lead on that vertical retrace circuit. I want to repair that a little bit better. I just did a solder blob on there to bridge my cut. Remove that cap I had installed while troubleshooting. And see if I can reduce that static on the picture a little bit. So here's twin lead coming in, and it's going down to this antenna terminal where I've got a balun going to my over-the-air converter box. A nice new balun, and it's either brass or gold plated. The video cable is gold plated, but these terminals are kind of corroded steel, so I don't have the greatest connection there. Make sure all the shields are in place. Well, I did the simplest thing first. I simply swapped out the two tubes in the tuner. Couldn't tell you which one made a difference, but the picture's looking a whole lot better now. There's one last thing I want to do. Put the fine tuning into the center of its range. I want to tweak the local oscillator. Trimmer cap, there's one for each channel inside this turret tuner. That's what this funnel's for. It's meant for when this chassis is inside the set, so you can feed a long tool down in here in that cup just to help you get it in the hole. You want to use something that's non-metallic, that's got a flat end on it, like a flat-bladed screwdriver, but non-metallic. And, well, you stick it in the hole, and wiggle it around, and you feel like it got into like a screw head. And they said to do counterclockwise first. I guess maybe to break loose the coil. Oh, in case it's already bottomed out. Yeah, that makes sense now. You wouldn't want to crank it clockwise. Potentially damage something, so they say go counterclockwise. What I want to do is get the best image and sound in the center of the fine-tuning range. Alright, so I'm going counterclockwise. Sound's fading out. Picture's kind of faded out. Go back the other way. I'm going to go clockwise a bit.
What it takes to protect. As a doctor, I agree with CDC guide. Pain relievers for unpause patch large. It's powerful, FDA approved to relieve pain.
Pretty good picture and sound right there. And if I tweak the fine tuning to either side.
Stop suffering with My Pure Mist, the only handheld ultra pure steam inhaler. My Pure Mist is proven to provide fast, natural, drug-free relief from allergies, sinus congestion, sinus pain, dryness, colds, and flu.
I think I got it.
Gently showers your sinuses with micromist for superb, natural, drug-free relief. No wonder 9 out of 10 users get instant symptom relief. Get My Pure Mist risk-free at Target, CVS, or Amazon.
Okay, so that basically completes the electrical restoration, which brings us back to the cabinet that we haven't seen probably since part 1. So I need to clean this out. There's some dust and debris down at the bottom. There's the remains of some of the yoke covering and some crunchy bits from the control harness that fell off. And then, so that's where the volume and power contrast control goes. I'll have to fit that back in. And on the side there is where brightness, a range, low-high, RF gain switch, and vertical hold goes. And then that is where the tuner goes up there. And here's another look at the tube chart. Notice for V402, it's a 6AL5 or 93A5-2. The 93A5-2, that's the version I have. That's the selenium rectifier, or dual rectifier for the horizontal sync discriminator. And notice that the picture tube was stamped on here. I'm sure they just changed picture tubes over time, since it has supposedly a 21ATP4 in it. It's got a warranty date replaced, so this is not the original. Looks like it was replaced. I don't think we noticed that before. It's replaced July 5th, 1956, it looks like. It tested okay when I tested it earlier. So that's when the high voltage goes in, and looks like the conductive coating is okay. I gotta see exactly where the grounding thing must connect up top. There's like a hoop that brushes against that. I'll clean off some of this dust and I'll see what kind of condition it's in. I can spray in a little more coating if I need to. So that is what forms a filter capacitor. That outer grounded coating, the glass, and then the inner high voltage coating. And then finally got to do something about that. If you recall, when I got this set, that pin there, that's the focus pin, and somebody just soldered a wire right to it. So the Thomas picture tube, and I don't think it's a rebuild. 21ATP4. So yeah, I'm going to clean up all the dust. And then after I get this cleaned out, I notice on the front you can remove the safety glass and then clean the front of the picture tube and the back of the safety glass, because that's kind of dirty and dusty as well. I notice this cardboard up top too with some tape, but I don't know what the heck that is there for. I thought maybe it had an internal antenna, but no, it appears to be doing not much of anything, so maybe some sound damping. Oh, which reminds me, yeah, that's the speaker. Yeah, the speaker goes on the side. There was one thing I was forgetting. When I started on this project ages ago, I put all the hardware in this coffee cup, along with the centering magnet and ion trap magnet. So hopefully I've got everything I need to put this thing back together. But I will save that for the next installment.